So today we are going to learn longest subarray with some k. With some k, only today we are going to learn positives and zeros. Let's try to write the optimal solution for this. So we're going to write the optimal solution. Let me first explain my thought process, how it's going to work. Let's try to analyze. What I say is, if this is the pointer, and I was going to the array, and I was increasing, increasing to the array, and I was increasing. Let's say I'm moving right to the array. Then the summation is also keep increasing. Summation is also keep increasing. But the summation here given is k equals to 6. We should need to find this summation, and we should need to return the longest subarray. We should need to return the longest subarray length, right? This is the summation we have given here is 6. And what I'm doing in this approach is, so this is a two-pointer approach. Or you can also say greedy approach. So again, how is this going to work? So this is the pointer I was pointing, and I was slightly increasing. And when I was increasing at the right, then the summation is also increasing. When the summation is greater than 6, when the summation will become greater than 6, then I should shrink this element. These are the elements, right? I should need to shrink this element. I should need to shrink this element until it becomes summation equals to 6. I should need to do that. So this is my thought process. Let us try to understand by doing the dry run. Let us try to understand by doing the dry run on this. Okay. Let's try to dry run. I say I'll take a pointer which is pointing to the first element. Obviously. Then the summation is equals to, here the summation is pointing this one. Then this one itself is a subarray. Then the summation will become 1. The summation is 1, and length is obviously 0, because we have got this is the first array, and it is 0 obviously. The index is 0, right? Okay. Let's see. What I say is, summation is not equal to k. What I say is, then I move. When I move, the summation will become 2. When the summation will become 3. Okay, summation is not equal to k. Then what I do? Then I move. Then the summation will become 6 now. The summation will become 6. Okay. It's equal to 6. And it is equal to 6. What I say is, I just need to find this length. This and this. So how could I find the length? Subtracting this with this, then I get the length. If I subtract this both, then I get the length. So what will be the length? The length now is, obviously the length is 3. Okay. But this is not the longest subarray length. We need to find the longest subarray length. Then what I'm gonna do? I'll move. When I move here, the summation will become 7. And it's not equal to k. And it's greater than k, right? What I should need to do? The summation has exceeds. What happens here? The summation has exceeds. What I should need to do? I should shrink. What I'm going to do is, I should shrink this first element. I'm going to shrink or I can say I should remove this first element. I should remove to this first element un, until the summation is equals to 6. Until the summation is when becomes 6. If I remove an element from this, then it will become 6. Right? Okay. Let us try to shrink this thing. When the moment I shrink, then I'm pointing here. Then I'll be here. Because this is shrinked from the array. Then the summation will become it will become 6. Again it will become 6. Then I move again. Then it will again become 7. Again become 7, and which is not equal to 6. Which is not equal to 6. Which is not equal to 6. Then I say again shrink 2. I say shrink 2. What will be shrink? What will be the summation? The summation will become 5. The summation is now 5. Then I again move. Then summation will become 6. The summation is become 6. The summation is become 6. Let us try to find the length. How could I find the length? I have told you this. When you subtract this with this, then you get the length. Then you get the length. What will be the length? What will be the length? This is 4. The length is 4. What will be the length? The length is 4 now. What will be the length? The length is 4 now. The length is 4. The length is 4 now. So this is the highest length. This is the longest subarray. I say 4. But we'll iterate. We'll iterate. I say I'll move. Then what will be the summation? The summation will become 7. The summation will become 7. What I should need to do? I should need to shrink this 3. Then what will it become? 7 minus 3, 7, 6, 5, 4. Then the summation will become 4, right? What I say? Then I say allocate. Then I say move. Then I say move. Then the summation will become. Then summation will become 7. I say shrink this one. Shrink this one. And it's pointing here. Shrink this one. Then the summation will become 6. And I say I'll move. Then the summation plus 3. Then summation will become 9. Then the summation will become 9. What I say? I say shrink. I say shrink. Then the summation will become 8. I say again shrink. Then the summation will become 7. I say again shrink. What will be the summation? The summation will become 5. The summation will become 7 minus 3. So it's 5. The summation will become 4. The summation will again become 4. What I say is I'll say summation will become 4. Then I say, then I can I point, can I iterate here? Here the iteration is over. The iteration is over, right? The iteration is over, and we got the length here is 4. We got the length, highest length here is 4. So this is longest subarray with some k. Only the positives and zeros. Only for the positives and zeros. This is the optimal solution. Let's try to analyze the time complexity for this. Let's try to analyze the time complexity. I say, then what will become the time complexity? I say that the time complexity is big O of 2n. Then you can ask me how you can say the time complexity is big O of 2n, right? I say I was using the while right. When I was iterating to the right, will be, this is the time complexity is big O of n. And at the same time, I should have to shrink the elements. Whenever the summation increases, I should need to shrink the elements, and I should also move that. For that, I should need to write a loop. Then you can say that then it will become n into n. You can say n into n will become n squared. Then how can you say it will become big O of 2n? So let's try to understand what is happening here. Let's try to understand. I say, when I was here, let's try to understand. So this is the array. This is the array. These are the elements. Try to think like that. When I am here, this is my first iteration. This is my second iteration. This is my third iteration. This is my fourth iteration. This is my fifth iteration. This is my sixth iteration. And this is okay. When I'm here and I'm shrinking, that is also an iteration. Here we have shrink. This is also an iteration. Here again we shrink. This is also an iteration. Here again we shrink. This is also an iteration. This is here again we shrink. This is also an iteration. Here again we exceed. We move. We move. We move. This is an iteration. 10 is an iteration. Here 11 iteration. Here is 12th iteration. Here the 13. Here it will be the 0 iterations. Here it can be the 0 iterations. Here it will become 14. And here it will be 0. It will become 15. Here it will be 16th iteration, 17th iteration, here 18th iteration. So this is how the iterations are going. For these all iterations, the time complexity will become big O of n. Big O of n. Big O of n. For these iterations, the time complexity will become big O of n. Then both, when we combine, then the time complexity will become big O of n plus big O of n. Then the time complexity will become big O of 2n. Yes, this is our time complexity big O of 2n. Right? Okay. At the worst case, this is at the worst case. This will be for the worst case. Let's try to understand what is the space complexity. Space complexity will be big O of 1. Obviously, big O of 1. Okay. So this is how we find the optimal solution for the longest subarray for the both positives and zeros.